This question is all about how you can go from an exponential to a straight line by using logs. So I'm going to jump straight into that. I think it's actually a really good shout to do. So v is ab to the t. Let's take log of both sides. I'm going to do base 10. I'm not going to worry about writing base 10, to be honest. It's implied. So log v is log ab to the t. Then I can separate it. Log a plus log b to t. Note you can't bring the t out yet because the a is not raised to the power of t. And then I'm going to get log a plus t log b. So this is now in the form y equals m x plus c. That's why we get a straight line if we then plot log v against t, which is what's been done here. So we can now read off the graph that log a, because it says what is the initial value of the phone, that's going to be my a. Okay, because it's when t is 0, we just get v is equal to a. So log a is the y-intercept, it's just going to be 3. And therefore a is 10 to the power of 3. That's how we undo the log, because it's log to base 10, which is 1,000. So the initial value of the phone, I'm just going to write in pounds, 1,000 pounds. And the complete equation for v in terms of t, given the exact value of a, which we've already got, and giving the value of b to three significant figures. So let's focus on that. Log b is actually the gradient. So the rise over the run, 2.79 minus 3 over 10 minus 0. This becomes minus 0.21 over 10, so minus 0.021. And remember that is log b. So then b is 10 to the power of minus 0.021, which ends up being, put that on your calculator, 0.95279. I always write it to a few more figures than needed. I'll just put it in actually, because we'll be using it in a calculation in a minute. There we go. All right, so my complete equation is going to be v. I'm just now putting them into here. V is going to be 1,000 multiplied by, we're asked to give b to three significant figures, so 0.953 to the power of t. Finally, we're asked to evaluate the model. Exactly 2 years after it was bought, the value of the phone was £320. Use the information to evaluate the reliability of the model. So remember, we're working in months here. After 2 years, t is actually going to be 24, 2 lots of 12. So model prediction thousand times 0. Now I would actually use the non-rounded version. You'll get away with it in A level, but best practice in science is to use non-rounded versions if you're then doing subsequent calculations. So I've got my answer already here, just raise it to the power of 24 and multiply by 1,000, which gives 313.32, which is very close, it's got to be said, to 320. So I concluded that, yeah, value close. So model is reliable.